Well, hello there, and welcome to Travis Laboratories here in the heartlands of Botley in the chalet. So Peter's insinuated that one can blow up or destroy beer on an induction hob if it's in aluminium cans, and I'm quite happy to try that. So basically I showed a picture of my craft beer tins stood on what was clearly an induction cooker, and Peter wondered if I was going to sterilize them or something like that. But anyway, for Peter's benefit, I'm now going to try and blow them all up by putting them all on my induction stove. So first of all, a few things about the equipment. As you can see, we've got the three-phase inlet here, so that's necessary to power the kind of industrial equipment you'll find here. And here we have our 7 kilowatt industrial induction hob. So without further ado, let's see what it will do for a regular tin. So this is a tin of, well, it's an old soup tin, and it's obviously made from plated steel. 3, 4, 5, 6, 7, 8, 9. So that's loads of power now going into our plated steel tin, which I've got some water in. So we don't seem to have a problem with that. That's now up to power of 9. So that's a lot of energy now pulsing through the primary windings, which comprise the induction hob, and the secondary, basically two halves of a transformer, which comprises the steel tin. Now the steel in the tin is conducting, but also offers a moderate resistance, allowing eddy currents to form, and those currents of course then turn into heat. And already we're getting some noises coming off here, and very soon it'll start to boil. So we've already got some steam coming off now. We've got a high power draw. As you can see, the heat not at all hot here, but the energy going straight into the base of the can and straight into the water. So this isn't hot at all. This, that's very hot indeed. And there we go. So we're just coming up to boiling. See a bit of steam coming off here. Now of course, if this was a closed tin, we'd be now looking at a massive explosion. We'd be looking at baked beans all over the ceiling, and a lot of damage. As you can see now, that's now boiling, and there we go. So one tin, and it's boiling like mad now because there's a lot of power going into that. That would undoubtedly cause a terrific explosion if that was a closed system. So let's now continue this experiment and just take the risk with a whole load of that expensive craft beer. So now you can see I've got some Cornish craft beer in the traditional aluminium tins here. Now this is very expensive. Whale's tail, you can see that it's very expensive strong beer. That's 8% by volume, that is 7.5%, and 5.5% Cornish IPA. And just to good measure, I'm sure that Pete would like to see these destroyed, and also chucking it in of his favourite, here we go, Schofferhofer, because he'd like to see that destroyed as well as a competitor to Growy. So I've got them all now lined up within the, if you can see there, the blue circles. It's got them all lined up. So we're going to try to blow these up, and it's just too bad if they do blow up. My loss. But let's see. Okay, so we're now going to crank up the power, and again, here we go on the lower hot plate, and we're getting 1, 2, 3, 4, 5, 6, 7, 8. Oh my goodness. Oh, well, what's happened? we seem to have a return to 0. Let's try again. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's and we seem to have hit a 0, 2, 3, 4. This could all blow up at any second. So we're still putting some power into it. But what's no? We've got a no pan mark. That means there is nothing detected on the hot plate. So try that again. 2, 3, 4, 5, 6, 7, 8, 9. Up to 9, but no, nothing. 2, 3, 4, 5. Let's just leave it at that. See if no pan. Okay, let's try a small amount of heat. Just up to 3. No pan detected. So there you go. So it's not detecting a pan there. Let's get rid of most of these because we just had one tin before. Let's just put some of this whale tail. Stick that in the middle like I did with the tin can. And let's just see what I can do with that. So 1, 2, 3. Let's leave it at 3. See if it will take. No pan. Sorry, no pan detected. 4, 5, 7. Up to 7. Go on, blow up. No pan. Can I get it up to 9? Yes, no pan detected. Okay, so let's repeat that test with the steel can. And here we go. 1, 2, 3, 4, 5. Seems to stay there. 6, 7, 8, and 9. And it seems to be taking some power again, so there we go. And that, as we've seen before, is now simmering. Drawing power, you can hear it, and that's going to boil. So again, if I push that off there, it just the 9 stays for a brief moment, and then it says no saucepan detected. I'm going to put the whale's tail back. No saucepan detected. Try the chauffeur hofer. No, nothing there either. So there you have it. Terribly sorry to disappoint. I know we'd all love to have seen an explosion, but basically, in the day, aluminium does not work on an induction stove because aluminium is highly conductive. It's just about as conductive as the wiring on the primary wiring, that is on the induction stovehob itself. So basically it means that there is no effective resistance, and the induction stove electronics just shut it down because it can't transfer heat to the can, or rather if it could, it would blow itself up in the process. So you can't use copper or aluminium, or indeed gold or silver on an induction stove. It's got to be something which is conductive but offers a moderate resistance. Usually the saucepans I've got have all got plate steel in their base. So you can see that all these have got plate steel. They're not copper, they've got plate steel with a copper surround, and it's the plate steel that confers the induction properties. So that concludes the lesson from Eaglehead Laboratories here in Botley. I hope you're satisfied now. So if you want to destroy craft beer, putting the tin on an induction stove will not do the job, I'm afraid. And with that, I'll bid you good night, and yep, see you all soon. Cheers for now. Bye bye.